वो नंबर नहीं बोलना है उनको, नंबर नहीं बोलना है,
स्टार्टिंग है क्या?
नंबर उनको क्वेश्चन पूछेंगे तो नंबर क्या देंगे, विच नंबर दे शुड कॉल,
वो बताएंगे अभी, आपको लिख के आ रहा है। रेडी? हाँ, ईयरफोन नहीं है मैडम, वो बता रहे। रेडी?
Good afternoon viewers, especially children. As we are all aware that NCERT has come out with the new textbook based on NCF 2005. Today we are going to discuss about science textbook of class 10th, where we will talk about chemical reactions and equations. So we are going to discuss this, and we have with us Dr. Alka Mehrotra and Professor R.S. Sindhu. I am Anjani Kaul from Department of Education in Science and Mathematics, NCERT. Before starting the discussion, let me briefly tell you what all is there in this particular chapter. Well children, in class 7th and 8th, in class 9th, you are little aware about chemical changes, where in class 10th we are discussing about these chemical changes in detail. And apart from this, we will talk about balancing of equation, why we should balance equation, why balancing of equation is important. And then we will discuss about different chemical reactions such as combination reaction, decomposition reaction, double displacement reaction, oxidation reaction. And if you go through this chapter, you might have seen that we have tried to relate the introduction related to the daily life situation. Before I exactly ask the question to one of our experts, I would like to throw some light on this, that for symbols and formulas you have read till class 9th. In class 8th you have you know more about word equation, whereas in class 9th you are more aware about symbols and how to make formulas and all. Now balancing of equation we have introduced first time in class 10th. So before that I will ask Dr. Alka that since children they are aware, little bit aware about chemical reactions till class 8, they have little idea, but can you please elaborate on this, what exactly are chemical reactions? Are these chemical changes?
Yes, of course these are chemical changes, and these occur when some heat changes, some light comes out, and sometimes sound also is seen in that. But it is not necessary that always a chemical change will accompany these changes, and moreover physical changes also accompany these changes. So sometimes it is difficult to find out the difference between chemical change and physical change. So to do that, we should know little bit about from our intuition. For example, if I say that fruit ripes, so there is always difference in the color of the fruit, unripe fruit, and color of the ripened fruit. So from the color change we can say that there is chemical change. Similarly, if we say that this thing has burnt out and has become black, then also we can easily say that it is chemical change. But if I tear the paper and I would say I can't bring that back into the original form, then it is very difficult to say whether it is a chemical change or a physical change. In that situation, we have to decide how we should decide that it is a physical change or a chemical change. For that, we should know that whether the substance as such is changing, or some bonds are breaking into it, or some bonds are being formed into it. And if we know this thing in detail, then we can say that yes, of course it is chemical change or a physical change. Apparently it seems that tearing the paper is a chemical change, because we can't bring back the paper in original form so simply, and in general we classify physical change and chemical change in such a manner that we say that physical change is such a change in which we can bring about the original form of the substance.
This means, can I interrupt you here? This means that while you are talking about a paper, you said, you gave this example right now. If I say that we have a paper, and the way you said if you tear it, this means this is a physical change, because we have not changed the state of that particular substance. But if I say if I burn it, then what do you think, that is this if I burn it and it will become black in color, So then is it a chemical change or a physical change?
Of course, it is a chemical change because now it has changed into new substance, that is carbon. In paper, sugar molecules are in a linear chain, which children will learn in the higher classes, not now, and that change, by tearing the paper, that change is not taking place in the chain length. But when we talk about burning of the paper, that becomes black because now it changes into carbon. So that is of course a chemical change, that is not a physical change.
Okay, well, the way I said in the beginning that Professor Sindhu, since you are the coordinator of textbooks of upper primary stage, you're very well, you know that children are aware about word equation till class 8th, and in class 9th we are first time introducing symbols and formulas. Now, what I would like to ask you that when first time when you are doing it in the classroom, this particular balancing of an equation, first of all I would like to know, do you think that we have to balance the equation?
Yes, we have to balance equation because we know that mass can't be destroyed or created. So that I mean that is a sort of conservation of mass is there. So when substances react with one substance reacts with another substance, so products, mass of products, some mass of product would be equal to the some mass of reactants. So that is needed, or in another way we can say that types of atoms on both sides, one particular type of one particular type of atoms on both sides should remain the same. So naturally then mass would remain conserved.
Yeah, very nicely you have said that about that reactants should be equal to products, but this means that you are talking about law of conservation of mass, which I think children they have already learnt in class 9. So it will be easier for them to understand what exactly is balancing of an equation. I think that is why deliberately we have left some equations in between unbalanced. Why we have left these equations unbalanced? So that once a child will understand how to balance an equation, they can go back to those equations and then balance them. Usually children think that why we have left this equation as such, we have not balanced that. We get that kind of feedback sometimes, but we have raised that question that this equation is not balanced. This means that children should try to balance it since they have now learnt it. Now, sir, usually when we write an equation, which we have said in our textbook, that put a square, don't write anything in the square, write somewhere on the other side, because at the end when we balance equation, we remove this box, for easier way to learn. So, how a child should start actually, look for an element which has got maximum atoms, or how to start that?
So, first of all, we see in reactants and products which compound is having, which formula is having maximum number of atoms, and amongst those also which type of atom is having which type of element is having maximum atoms in that. So we start with that. First we start balancing the number of atoms which in a particular case which are maximum.
Okay.
So there are some cases we can simply take example of reaction of iron with water. So Fe3O4 Fe reacts with H2O and it gives Fe3O4 plus H2. So then we can balance it. So in this case Fe3O4 is having maximum number of atoms, and in that oxygen number of oxygen atoms is maximum. So we start balancing the number of oxygen atoms on both sides, and then we proceed further in balancing other elements and number of atoms of other elements.
Okay, when we once we balance the equation, then we try to write the physical states, in between the brackets we usually write physical states. Well, Dr. Mehrotra, do you think it is necessary to write these physical states in between the brackets? Is it necessary, or we can skip that? Or if it is necessary, why? If not, why?
If we write gases is G for gas, L for liquid, and S for solid, that means that we are telling the state. This is the thing, this is the convention that we do sometimes. But it is not always necessary to report all these things. If we write, this is good, because then we are telling all these states, states of all the compounds, and in that situation we can get complete information about the substance. For example, if I am dissolving sodium sulphate in water, or I am reacting sodium sulphate with barium chloride solution, in that case I know that sodium sulphate, if I have taken in the solution form, we write aqueous for that, means it is in the solution form. But if I write Na2SO4 as such and do not write anything about solid or liquid or anything, that means I do not know whether I am dissolving the solid in the solution, or it is in the solution, or it is in the some other state. So, it is very important to write it, but even if we skip sometimes and we know that at normal conditions this substance remains in the solid state, then it is understood that we have taken it. If the reactions are taking place in solutions, then also it is understood that it is aqueous form. It is not necessary in that case that we should write aqueous or something in that,
well,
but it will be nice if we write
okay,
it.
I'll get back to you, but viewers, as you know that this program is specifically for the children, and we really welcome the questions which children will ask, and I am going to give you the toll free number, that is 10011219999, and the other number is 1800112199. I will repeat again, it is 1000112199 and the other is 1800112199. Please feel free to ask these questions, whatever questions you have, but please be concise to this particular topic. I am again repeating the topic. Those who have switched on their television little later, we are talking about chemical reactions and equations which are in class 10th science textbook of NCERT. Right now you said Dr. Malhotra that when we say L, this means water is there. When we say
no, not L,
okay.
L means liquid.
Okay.
If we write AQ in the bracket, then that means it is in the solution,
Okay.
and that too in water.
Okay.
Aqueous means water.
Okay.
If there is some other solvent, in that case we write SL solvent, SL is the symbol for solvent, otherwise there is no need of writing.
Okay. This means if I put it this way, that in class 10th, if we are asking them to write the physical states, then our children should really focus on that, because otherwise, because whenever you write equation, it is very difficult for them to write, you know, all the time in brackets, isn't it, Professor Sindhu?
Yeah, right.
Now, there is one more thing, you know, if you go through this chapter, you see that the way you said, Professor Sindhu, that we have reactants on one side and the products on other side, and then we have an arrow. So, sometimes we write, you know, on the top of the arrow or below the arrow, like atmospheric pressure or some temperature or some catalyst. What does it signify actually?
Actually, that signifies that the conditions which are required for carrying out that reaction, maybe atmosphere, maybe catalyst, maybe some atmospheric pressure, maybe there, maybe temperature or pressure. So, these conditions are mentioned because there is a place for that on above the arrow or below the arrow, we write these conditions.
This means suppose this means basically we are trying to put things together, you know, instead of writing a big paragraph, this much temperature and this is the catalyst. So, it is better to write on an arrow and put those conditions there. Okay, and
Anjani, I would like to highlight one more thing about it. It is a shorthand notation for writing chemical formula. In fact, if we write very big paragraphs for a equation, it won't be easier for us to comprehend it. Therefore, it is a shorthand notation in chemistry, as and sometimes writing a paragraph, for writing a paragraph we write some symbols. Similarly, it is also a shorthand notation for writing chemistry.
Yeah, this means that this is basic, that is why we say chemistry has its own language, you know.
Yes.
So, that is where you are putting it. Thank you very much. Now, Professor Sindhu, since we said that we are going to talk about you know, different reactions, we are covering combination reaction and other reactions. Let me start with this, how a child should understand what exactly is a combination reaction.
In combination reaction, two reactants react together and one reactant, one product is formed. We can take example of H2 and O2, these react together and form water. H2 plus O2 will give H2O. So, that is that means
Combination.
these two elements are combined together to form a compound. So, that is a combination reaction.
So, you mean to say that in combination reaction we are going to get always a single product?
Yeah. I mean, since here combining of two elements is taking place to form one compound. So, that is combination.
Okay. So,
We can take another example, calcium oxide reacts with water, it gives calcium hydroxide.
Okay, right now we are having a telephone call from Chennai, and please go ahead with your question, please. Chennai. We are looking forward to your question.
Hello?
Please feel free to ask the question.
Hello? Hello?
Well, I think we are
How
not
you
getting the
referring to
connectivity
three?
right now. Professor Sindhu, the way you said that combination reaction is like you talked about calcium oxide reacts with water to get for example, calcium hydroxide, and you know, since we have given it in a box item that whitewashing, you know, that kind of concept we have given as in whitewashing, that usually when we put it, it's a calcium hydroxide and gradually it combines with the atmospheric carbon dioxide and we get a shine, you know, on the walls. This I would like to highlight here, that we have given so many, you know, box items in between the textbook. These are non-evaluative, and why we have given this, we want the children to really understand certain things in depth if they want. We don't want to burden them unnecessarily, because these may be beyond their, you know, cognitive level, but if they want to know, they can read further. That is what we say in National Curriculum Framework 2005, that we can go little beyond textbooks if we want to know. Now, let me see that we are again getting a question from Chennai. Yes, please.
Hello? Hello? Hello?
I think it is not getting connected. The moment we will get connection to this, we will definitely take your question and would like to answer. And well, we have tried to relate this chapter with daily life situation. Why do we focus all the time? Why do we say that we have to relate it to the daily life situation of a child? I mean, can you answer something? Why do you want exactly this?
Anjali, actually chemistry is such a subject that in daily life we experience lot of experiments. Even in kitchen we find many things which are related to chemical changes, and this makes the subject very much interesting if we try to understand what is happening to the particular substance. For example, if we take lemon juice and put it in the copper vessel or in some other metallic vessel, what happens? It dissolves, acid dissolves that particular metal and substance may become harmful. For example, if I put lemon juice in copper vessel, it may become harmful for the person. So, if we understand these things, then it is very interesting for us, and it helps in our life also. Therefore, we should try to understand these things.
I think that is why, you know, these kind of questions are usually asked by children, that why we should not put you know, curd in a copper vessel, or you know, things like that, or if we can put it, how long we can keep it there, you know, that is what you are trying to connect it. We have like Dr. Professor Sindhu said about combination reaction, we talk about decomposition reaction. What exactly is this, Dr. Alka?
Actually, the particular substance completely decomposes. For example, if I heat sodium bicarbonate, it decomposes into carbon dioxide and sodium carbonate, and water vapors come out. So, there is complete decomposition of the particular substance. These are specific examples, the combination reactions, and this particular reaction which I am talking about, or displacement reaction which we will talk about next. But sometimes it so happens the combination of these reactions takes place. So, in this class we have taken only those examples which are particularly related to this particular thing. For example, combination reaction which Dr. Sindhu has told is a particular example of that particular reaction in which only combination is taking place. This particular example is of decomposition only, nothing else is taking place in that. So, this way we can identify a particular type of compound in other reactions also.
Simple example we can take ferrous sulfate. It decomposes to give Fe2O3, SO2 and SO3. So, that decomposes.
So, how a child will come to know that this gas is SO2?
Of course, there are tests for that from the smell, of course. Here from the smell
at this
we can.
stage a child can smell, you know,
only
usually we say that you keep your test tube like this and don't bring it close to your nose, don't smell like this, you simply, you know, push the vapors towards your nose and smell it. I think that is the way one can.
In case of sulfur dioxide, smelling will do.
But this is the kind of example which you give right now, I think is we talk about this is actually a thermal decomposition reaction, isn't it? Now, one of the reactions we have given where we are passing, you know, electrolysis of water we have talked about, and here we have shown that, you know, we take 2 carbon rods and then we put you know, test tube filled with water and you invert it on that and then you get hydrogen and oxygen. And here in one of the sentences, which usually we get this question, in one of the sentences we have written that add few drops of acid. Why should we use few drops of acid, Dr. Alka?
Actually, water is a covalent compound which children will learn in the next chapter, and this covalent compound does not give so many ions that electricity is conducted into that. Therefore, we add some sulfuric acid to it, so that conductivity increases and water electrolysis takes place. Otherwise, there will not be any good conduction of electricity and decomposition will not occur. Not visible, or rather, I should say.
And one more activity we are talking about, silver chloride, where we are trying to say that keep silver chloride somewhere in sunlight and then you see what will happen to the silver chloride. That is also there where we are
decompose in the presence of sunlight. It decomposes to give, if you take example of AgCl, it decomposes to give silver and chlorine, and AgBr that decomposes to give silver and bromine. And in fact, this phenomenon, this type of reaction is used in photography also.
I think that is also we have mentioned somewhere in our textbook that this is actually useful for photography. Well, we are talking about reactions and we are talking about like we see sometimes, you know, when we add, for example, if we put zinc in sulfuric acid and we see bubbles of hydrogen gas coming out and we can test the hydrogen gas. But sometimes when we touch the beaker or a conical flask, wherever in which you know, container we are doing an activity, we find it a little warmth, you know, little you know, when you touch that you feel some heat is as if generated. What is that, Dr. Alka?
Actually, not only heat, sometimes we feel that test tube has become cold also. So, this means that some exchange of energy is taking place during the reaction and it is either being absorbed or it is being released. And when it is released, we find heating of the substance, and when it is absorbed, we find cooling effect. So, this way we say that exothermic reaction is taking place when energy is going out, coming out, and it is a endothermic reaction when energy is absorbed and cooling effect is seen.
Professor Sindhu, I would like to ask one thing, like Dr. Alka said about exothermic and endothermic reaction. There is one reaction which I would like to specifically talk about is barium hydroxide and ammonium chloride. You know, when we mix them together, we get a feeling of, you know, cold. When you touch the test tube or beaker, you feel a, you know, cold feeling is there, and we say that it is a endothermic reaction. Well, for this activity, we have to specifically take certain, you know, precautions for that. Can you please highlight on this issue?
Actually, this is very important thing, and especially when we were talking about that we should mention the state. In a chemical reaction, we should mention the state of the substance. And if you ask some students, okay, I am writing this equation and you now perform this reaction. So, if we have not mentioned the state in that, it is bound to happen that students would be committing mistake in that case. Here, in fact, what we think is that we say mostly in chemical reactions at lower level, we say that you prepare the solution of one substance and solution of another one and react together, other substances are formed. Here case is totally different. Here we take solid sodium, solid barium hydroxide, solid ammonium chloride, and then a glass rod is taken, and then it is mixed together, and then in fact immediately after some time we will see that gas is evolving out, and if you touch the test tube in which we have taken these two substances, you will see that even your palm starts cooling. So in this case it is required that we should have both the substance in solid state.
And if we take it in a solution state?
Yes, of course, you won't see any change. In fact, what happens is that if you take barium hydroxide, when you dissolve that in water, this is a physical change, and that is an exothermic physical change. And when you add ammonium chloride in water, that is endothermic physical change. So these two changes have already taken place, and then when you add these together, reaction won't take place, because in most of the endothermic reactions small molecules emit out. That is an indicator of an endothermic reaction. Either carbon dioxide may be there, ammonia may be there, glycine may be there. I mean, small molecules emerge out. That is the indicator of endothermic reaction. Here in this reaction, ammonia is evolved. So
yeah, it's a very good reasoning which he has given, because we have tried this reaction couple of times, and whenever you make solution it is not possible to get the results, and if you really take them in solid state and stir them, mix them together, stir them, and you will really feel a cold feeling, and your hand can feel that cold feeling is there. Well, we have learnt about displacement reaction, Alka ji, maybe in class 7th. Not to that depth, simply we say that this is some displacement is going on. Now in class 10th we have introduced this displacement reaction. So can you please highlight on this, what exactly you mean by displace? Are we displacing something from somewhere?
Yes, yes, of course. There is one experiment in this book which we have given, that zinc rod is placed in copper sulphate solution, and what happens, copper sulphate loses its color, blue color is gone, and zinc replaces copper, means zinc has displaced copper, so, and it has come in place in the form of zinc sulphate. Copper has come out as metal. Earlier it was zinc which was in the metallic form, and copper sulphate was in the compound form. So copper has been displaced by zinc, therefore it is a displacement reaction.
Okay, since we are running short of time, and I think we have so many things still to discuss, and children in near future, whenever we will get an opportunity, we will interact with you back, and we will continue maybe this discussion, and if you you can feel free, write to us whatever topics you would like us to introduce in near future. And in the next session at 3:30 we are going to have a discussion on biology textbook of class 11th, and till then goodbye, thank you, and all the best, students.